We made it. It's the last session of another fantastic TechEd, and we made it all the way to the end. Well done for sticking with me all the way to the end. That's awesome. So today we're going to be talking about how to get started with Git. So we're going to really try and build up a good, strong mental model of what this source control system is. What is Git? And we're going to be talking through that at a real fundamentals level. I'm not going to go deep into any of the topics. I'm going to really stick to the how to use it, how it works, how to get started with it. So that's what today's going to be all about. And we're going to be really focusing on those basic commands. How are we going to be engaging with this system? I couldn't do a Git talk without talking about branching, because the merging and the branching story in Git is really what makes it so compelling as a source control option. So we're going to be having a look at the branching. We're going to be talking about what distributed means. You may have heard the term distributed version control system, DVCS. We're going to be really doing that, looking at what that means. I'm going to really briefly talk about putting Git on a server and the options that you have around there, and then trying to put it into a little bit of context for us as .NET developers. What does it mean for us in terms of Visual Studio? What about TFS? And we'll just have a quick look at that right at the end. Okay. So let's explode some brains. Are you ready to go? So just this fella down the front then, awesome. Well, I'll just go anyway. Before we talk about what a distributed version control system is, let's have a think about what a version control system is. What is it? Why do we need them? So that's fundamentally it, right? It's basically some way of recording the changes that we make to our files, because emailing zip folders of folders of code is bad. Just record the changes that get made in a way that we can restore. We can restore those previous versions if they need to be restored. If the current version has a bug, we can roll back. Okay? And potentially we can track who made the changes, what did they do, when did they do it. We can go and have that conversation with them. Say, well, why did this change happen? Because you realize it's broken this other part. So recording, tracking, that's what version control is, right? And for those of us that are familiar with centralized version control system, for those of us that have used TFS and SVN and those kind of client-server things, they allow us to collaborate in teams. We can all commit code into the same code base. And I'm guessing that those of us that have used those systems already have that reasonably strong mental model of what that looks like. You know, your history of your project, that all lives on the server, and you have a working copy of that code sitting on your client, on your PC. Okay. So some of the issues around centralized version control systems, some of the problems that you might look at trying to solve, may be it's very network heavy. By its very nature, the things that you do when you interact with your server, maybe you want to go and get the latest file to compare your changes, the changes that you're making, you want to compare with the latest version. That's a network call. Maybe you want to grab the latest changes off the server. That's another network call. Maybe you just want to take this little bit of code that you've got now and just put it away, just put it into the history. That's another network call. These things can be laggy. Maybe the server goes down. Maybe you're on a plane. Maybe you're not in range of your server. Certainly, some of these options do have offline experiences. They're not always great, and I'm being euphemistic and polite. So, a distributed version control system. A distributed version control system will work in terms of repositories. It takes the concept of a repository. And a repository is, in many ways, it's very much like your server, because it contains your project, it contains all the history, all the changes, who made what change, where and when, but it contains it on your PC, on your laptop. So it's fully offline. So you can engage with it. You can make those calls. You can say, add this change, add that change, do this diff, make that comparison. And it's all local commands, which makes it really fast. Okay. So I'm going to do some demos. I'm going to show you some basic commands, and we'll show you how to get started, and then we'll take it from there. Now, I've showed this slide a couple of times already today, and it's such a good slide. It just needs more air. We're going to use the command line with Git. There are UI tooling options available, but what I really want to focus on today is What is Git doing? How is it doing it? And honestly, the best way I can show you that is on the command line. Okay. So the first thing we're going to do is we're going to create one of these repositories. If a repository is like a server, if it's a story of our project with all the history and everything that's gone on within our project, then we need one of those. That sounds like a good idea. Okay. So at a command line, we can do this. Let me just go into, I'm not even in the right place here. So let's go into my repos folder and let's create a repo. Okay, so let's create a repository and let's call it TENS demo. Okay, so you probably can't see that. Excuse me. Let me just try and boost the font size here. It's bound to be one of these settings here. Let me see. Shout out if you can see it. Main. This one? Let's try that. How's that? Okay. So it's telling us it's initialized an empty Git repository. Cool. So we now have a new folder called TENS demo. So let's go and have a look at that. Let's go into that. What's in it? Nothing. We don't have anything in there. But what we do have is a hidden folder called Git. Let me just do this one instead, called .git. Okay, so .git is like our Git database, the thing that's going to power our Git repository. This is the first and the last time I'm going to show you this because it's kind of not really relevant to me as a Git user, but I just feel happy that I know it's there. Okay, so it contains all the metadata, all the information. It's going to contain all the stuff that I'm about to show you. It all gets stored in this little folder. It's just a file or a collection of files and folders on the file system. If we were so inclined and we were Uber users and we wanted to really optimize, we could create these files and these folders ourselves, and we could create the settings for the exact experience we want. But I'm nowhere near that, so I'm just going to go Git A NET. Okay? And incidentally, we could go into a code folder that exists, into an existing repository, into an existing folder, and create a repository by using the blank command Git init, and without specifying the name of the folder. If we give it the name of the folder, it creates a folder of that name and puts the Git database in that. If we don't, it just creates a Git database where it is. Okay? So Git init works like that. Cool. That was easy. You're away. Look at you, you're Git users. Wasn't that hard, eh? So now we have a Git repository. We want to start tracking the files, tracking the changes that are being made to these files. Git will do this for us. Now that we've created a Git repo, it will do this. And it'll even notice that there are new files that it didn't know about, it wasn't tracking, and it will tell us about those too. Okay, so if we create a file, we add it into our repository. Okay, so let's just have a quick look at what that looks like. So let's just create a file like a README document. Okay, and this is going to be, this is our file. Okay, so I'm just going to save that. I now have a file in the system. Now if I ask Git, what is the status now? What do you kind of look like? What changes can you see? Okay, it's telling me that it can see this red one here. Can you see that? It says readme, readme.md. That's the new file. It's saying, I don't know about that one. It's untracked. You need to git add that file for me to know about that file. Okay, so we can do that. Now, if I do GST, this is just a shortcut I got on my laptop, and that's just going to run git status. Okay. No, it's not. Okay, I'll do it the long way. Oh, do you know what? I'm in the wrong console. Just give me a moment. So I'm going to actually do this in PowerShell because I've got some shortcuts set up. Yay. Okay, so now we still have this new file, but we know about it now. Okay, so it's sitting there, it's green, it's good, it's new, Git knows about it now. Okay. So what that file has done is it's gone from our working folder, where we've just made a change to a file on the file system, working directory, and we've done a git add. And we've put it into the staging area, into the middle of these three areas. Okay, so Git has this dedicated area that allows us, we can make our commits and we can put our files into this staging area. So in very much the same way as coders, we take pride in our ability to turn in beautiful code. And that includes going back and changing and refactoring and making our code look beautiful. And what the staging area does is it gives us that same ability to refactor our commits. So we make a load of changes, and before we actually put it into our repository, before we commit it into the repo, we have this staging area that allows us to very individually pick the bits that we want to pick and create a beautiful commit, the same way as we would create our beautiful code. The thing that I'm referencing there, git-sem.doc, this is the documentation for Git. And if you're interested in learning Git from scratch, go read that book from end to end. It's completely worth it. Okay, so I've used the word commit a few times. And a commit is the end result of us gathering up the changes we want to make and putting a bundle around it and giving it to the repository and saying, here's the next step of your history. And once we've committed it to the repository, and Git says, yep, I know about that, that's logged, that's safe, it's in the bank. It will now clean our working directory, so there are no pending changes. Git has that change, it's done. Okay? The way that we do this is with this command here. So we use git commit, and we can add a message to that commit to just explain a little bit more about, well, what did we change and why did we change it? Okay. So let's have a look at that. So now that we have our README sitting ready to go, we can commit it. We can add a message, and we can just say initial revision, or this is the first commit, or whatever. Okay. So we've got some information come back from Git about what we're doing. And the only really interesting one here is the number. Right after it says master root commit, there's the beginnings of a 16-digit SHA. So that commit has a unique SHA, and Git will reference that all over the place, with merging, with branching. And that's probably the only really interesting piece of that information that's come back. It's told us that it's changed a file, it's made some insertions and stuff. Okay. So if we go back and have a look at the status, we're still on the master branch, and we'll do branching in a little bit, but it's telling us there's nothing left. Our working directory is clean. That doesn't, of course, mean that our working directory is empty. We've still got our code here. It's telling us that there's no pending changes to make. There's nothing left to be put into source control because we're clean. So inevitably mistakes happen. You might put something into a place you didn't want to put it. You want to bring it back. Okay, so undoing things is important, and it's not that hard because Git will help us all the way along. Okay, so let's say we want to take a file out of our staging area. Okay, we use the command here, git reset head. Now we'll be looking at what the head label means and what context it has, but effectively for now, git reset head is the command that we need to do to unstage a file. So let's say that we have another file. This is another file, can't even spell another right. Okay, and let's say we've staged it. Okay. So you can see that our file has been staged, and we've now realized that actually I've put that in the staging area. Like, if I now do a commit, that other file is going to go into our repository, but I just remembered I didn't want to do that. So we want to bring it back out, and it's telling us how to do that. It's telling us use git reset head file to unstage. So reset head file, and we've come back to an unstaged situation. We've got a pending change on the file. Git's noticed as a pending change, but it's no longer in the staging area. And if we try and do a commit, that another .md won't go. What if we really want to get rid of that change? What if we realize that we didn't need that file at all, or we didn't need the edits that we made on some other file at all? Yep, we can throw them away. Remember, but at this point, we haven't committed it into our repository. So it's not on the server, if you like. It's not in the repo. You need to be really, really sure that you want to, because once you've thrown these changes away, they're gone. You can't get them back. Once you've committed them, you can always get them back. Okay, so to do that, we can just use the git checkout file. It's a slightly odd-looking command. It includes a couple of dashes in there. But again, we don't need to be too scared of it, because it actually tells us. No, it doesn't. But we can just go git checkout dash dash. That's interesting. Oh, because it wasn't. So that's why it wasn't telling us that we could check it out, because it wasn't even known. So let me show you what I mean by this one, and I will simply. Let me just remove that file, and let me just edit my README. Okay. Change. Oops. Now let's have a look. Now we've got a pending change on a file that Git knows about because it's tracking this file. And so for us to completely remove that change from that file, now it's telling us how to do that. It's telling us we git check out the file. So if we have a look at our file, it looks like it did before we made our change. Okay? And we can just quickly check the status. We're all good, we're all clean, we got rid of that pending change. Not too bad, eh? Any questions? Phew. The really, really cool thing about Git is branching. Now, people say, branching is hard in client-server technology. It's hard in SVN. It's not. It's ever so easy in SVN. Merging it back in again's a bitch, but it's easy to branch. Git has a really, really good story around this, and the way that it stores its data makes merging, it's not pain-free, right? You have merge conflicts, you have to deal with that. But what it does, it reduces the opportunity for merge conflicts, and it makes that merging experience much, much nicer. And the reason it does this is that it comes back to the way that it stores its data. So we've talked about the concept of a commit. And a commit is effectively a collection of changes that you've made and some metadata to describe those changes. So you've got the commit message, you've got a timestamp, you've got the person, the user that made the changes. And the commit itself is made up of a series of files. They are the files. The important thing to note here is that Git doesn't store deltas. So it stores the whole file. And if you make a change from version 1 to version 2, the first file changed, A1, Git will store the whole of the file A1, not just the deltas that it made to A, and that's really, really important. What it allows us to do is consider that Git in that commit in complete isolation. Okay, now I know what you're sitting there thinking. You're thinking, crikey, it must take up huge amounts of storage if it's storing multiple copies of all my files. Remember that when Linus wrote this, he wrote it to manage Linux. So Linux is a pretty big code base, and he had two main goals in mind. Firstly was that it had to be fast, it had to perform well. And secondly was that it had to deal with really large code bases. So they have mad, crazy amounts of compression going on here. The files themselves, yes, it will store the whole file, but it will compress it down incredibly small. Okay, so just to recap, a commit is a pointer to the snapshot that we just saw on that picture. It contains some metadata, and it also contains, each commit contains some number of pointers to the parent. Where did I come from? In the first instance, we do our initial commit. There are no pointers, there are no parents, because it's the first one. In the second one, there'll be a parent, and the third one, there'll be a parent. And so let's have a look at what that actually looks like. Write some code, do a commit, we get a SHA. That's our initial commit. Git's going to put a sticky label, and that's all it's going to do. It's going to grab a sticky label and attach it to that commit, and it's going to say, this is our head. And what that represents is if you make changes to files, you'll be making changes to that version of those files. Remember that it knows every single file at a completeness level. It doesn't rely on deltas to previous versions. Oh, I should also point out, that these dotted ones, where A1 doesn't change from 2 to 3, it doesn't store another copy of A1. It just stores a pointer back to the existing copy of A1 on the disk. Okay, so there's that as well. Okay, so we've done our commit. We've added our head label. We attach another sticky label on, and we say this is our master branch. Okay, so I'm going to talk about branching in a bit. Again, in this context, the branch is simply another sticky label on the commit to say this is the master branch. So you write some more code, you do another commit, and both of those sticky labels move along. They both go from 98C up to 4C7. Okay, so now we're working on that second commit. Any changes we make will get added to that version. Okay, and so it goes on, and so the labels move on. Okay. So at this point, maybe we want to create a branch. Maybe it's a feature branch or a topic branch that we want to create the login feature. Okay? So we can do this with the simple command git branch followed by the name of the branch that we want to create. Okay? What's that? Literally, that's just going to take another sticky label and it's going to add it to the same commit. So we're now working on 56A90. There are two branches associated with that commit, and that's the one where we're working. That's our head, and we're currently on the master branch. Okay? So now that we've created a branch, we might want to switch to it. So we can just do a git checkout. And git checkout means go and work on that branch that I've just created. Okay? And there's just a little, mostly people don't do git branch followed by git checkout. For the most part, people will do git checkout minus B. Minus B means this branch doesn't exist yet, so can you create it, please, and then switch over. Okay. And all that does is it takes the sticky label off the master side of that commit and moves it to the login side. So now changes that we write, it's going to be on the same commit, on the same version of those sets of files, but it's going to be on our feature branch. So we write some code, we check it in, and so the head moves along with the login branch. Okay? Now let's say we switch back to the master branch, because there was some feature that we needed to add to the master branch. Okay? So we haven't affected the code that we were writing for our login page, but what we've done is switch back to our master, added some more code, and we've now got this divergence, this tree structure starting to build out. Okay? And at some point we're going to want to merge this back in Now, there's two ways that we can do this. And the first is by creating a dedicated merge commit with the git merge command. So what that's going to do, it's going to take all the changes that were involved in the login commit, all those file changes, and it's going to take all the changes of the latest version of the master branch, and it's going to play them, put them together, and it's going to build a set of changes, which is just another commit, and it's going to add it to the master branch, add it to the history of the master branch. So this bo4d3 commit is a dedicated merge commit. Its only job there is to contain both the parent references so that you know where these changes came from. You can see that it's pointing back not only to the one at the master branch, but also to the one in the login branch. But there's another way of doing this, and this is favored by some, and this kind of getting into religious war territory, but this is another way of doing it. We could also rebase our master branch based on the changes that we have in the login. And because of the way that we're storing self-contained versions of the files in each commit, what we can do is actually rewind our login feature branch up to the point where we've got the login page. We can then grab all the commits that have been applied to the master branch since we branched and replay them on top of the login branch. And the benefit there is that we've lost our commit, our merge commit. And some people will tell you that that makes it cleaner and that it's easier to read the history. There's always dragons, and the dragons that you need to be afraid of in this scenario is that when you rebase a branch, you completely re-alter all the history, including all the shars. So you're basically taking those commits and replaying them and generating a whole new set of commits. So if you've pushed a feature branch into a public place and people have got your code, they have those shars in their repositories. If you rebase something and then something that has been pushed, you're messing up everybody else's code bases. So it's one of those features where if you're working locally and you want to tidy up your commits before you push them into a public place, then rebase is very powerful, allows you to make very clean commits, clean history. Don't do it after you've already pushed it. Okay. So we're going to talk about working in a distributed fashion. What time does this finish?
35 minutes.
Okay. So let's recap. What have we covered so far? The reason we use a version control system is to record who made the changes to the files, restore previous versions, track who made the changes. A distributed version control system uses a repository-based system, and it's fully offline. We've already covered all that. So what does that mean in terms of actually sharing code with other people? Well, in order to be distributed, if I was in one office, someone was in another office, someone was on the other side of the world, we'd all have repositories, and they'd all look the same. My code would be the same as their code, would be the same as their code, and that's the same as the client-server model, right? We'd all have the same code base. One of the ways that we can, in order to avoid setting up multitude of peer-to-peer connections, one of the ways that we can avoid that is by putting a repository on a server somewhere. The only job of that repository is to just collaborate and communicate between the team. So you make your changes, you work, you push your changes into your repository, you then push them up to the server to let all the other people who also know about that server, let them know the changes that you've made, and they can pull those changes down. Now, it sounds like client-server, and in many ways it kind of is, but it is subtly different. So you're generating your clean commit history locally, and then you're pushing that history up onto a repository that sits on a server. And in many ways, it's just another repository. It's not like the server version of your code. So there's options here. You can create your own Git servers. You can install your own Git repositories. Definitely not going to go into the ins and outs of that today, because that's not in the remit of a getting started with Git talk. One of the very, very popular options, like we're devs, we know about this. It's GitHub, Bitbucket, even Codeplex. That Git support is reasonably prevalent now. And the benefits of using a hosted service like GitHub go beyond that pure ability to manage your Git repositories. There's the whole social aspect to it. So you can communicate with each other about your code, and you can chat like in the code at a line by line level. So there's a heap of benefits to using one of those sorts of services. Because fundamentally the repo that's on the server, it is just another repo, mostly. Okay, so how does this actually work? Well, if there's a repository on a server somewhere and it has a version of the code that we're interested in, then we need to get it down onto our machine, and we can use the clone command for this. And git clone will actually take all the code from that repository, and it will write it to my local file system. It'll take the code, put it on, and it will bring the .git folder. Remembering that .git folder contains everything we need to know in terms of the history and all the commits and the log. And what it also does is it sets up a link back to that server, so that we know locally how to grab the latest code off that server and how to push our changes back up. And it uses these things called remotes. Okay. There's three ways. There's three protocols that we can use. Git has its own .git protocol that we can use, and that's fine. We can use the SSH protocol, which for those of you that know a little bit more about Linux than me will know more about what that is. It's a way of communicating with that server, and again, you just have to give it some credentials, and then it knows who you are and what access rights you have to what parts of the system. And it will use that by default. So if you don't specify a protocol, that's what it will use. Or you could just use HTTP, HTTPS. Okay? So now we have a remote branch. And in many ways, it's just another branch. We've got our local master, and we've got our origin master, where origin represents the name of the remote machine. So the remote machine is over at that URL we just specified. We know where it is, we know how to get there, and we just give it this handy alias, and typically it might be something like origin. And we know what branch that's on. Okay. If we want to know more, about the remotes that we've got, we can use the --verbose command, and we can actually add aliases up to the remote machines, up to our GitHub servers and wherever they are, by using the command git remote add. So it's pretty straightforward. So we have a reference through to our origin master. We've cloned it. We've got the remote set up. We know where it is. We do some work locally. We can then ask the server, well, everybody else has been working. I want to get the latest for everybody else has been doing. And we use the git fetch command for that. Okay, so git fetch tells us, go to the server, bring it all down. And you can see that the origin has kind of progressed. So we're then left at a point where, again, we've got this kind of divergence. And again, we can use the same techniques, and we can just merge those changes back into our master. Okay, and again, you can override the fetch and merge as two commands. You can do them both at once with a git pull. And when we have code, we have our changes. We want to push back up to the server. We push back up to we reference the remote, the alias that we've set up for where are we going. We reference the branch we want to push to. And by convention, if we say master, it'll mean take our master branch and push to the master branch on the remote. Okay, but you can override that by specifying from my branch I've called hotfix, we can push it up to the branch called issue 53 up on the remote. Okay, so I just wanted to talk quickly about pull requests. When we talk about git pull, if you remember, git pull was the combination of git fetch and git merge. So it literally is what it says. It's a request to someone. Can you grab the changes that I've made, and can you pull them into your repository? Because I've written a great feature, or I fixed the bug, and I think it'll benefit your code base. Can you pull them in? It's a request. And the public Git hosting sites make this really, really easy. They encapsulate this whole scenario. You can do this stuff at the command line, but sites like GitHub give you easy ways to do it. So I'm going to try and do this. I'm hoping this is going to work. Let me have a look. I should have. Where is my code? Okay, so let's do this from the beginning. Let's log into GitHub. Sign in. And okay. So let's go here. So I've already made a copy of this repository. So there's a repo called code52/say what on GitHub. I've forked it, so there's a clone of that repository on GitHub. What I'm going to do is take a clone of my fork and bring it down onto my machine. Okay? So let's just grab the URL, go back onto here, and go git clone there. Okay, so that's going to go up to GitHub, and it's going to say, can you take Ian Randall's clone and bring it down onto the local machine? So in this scenario, I have no ability to write my code changes up to the code 52 code base. It's not my code, I don't own it. And you may have a scenario where you've got teams of devs working. You don't want them committing straight into this branch because this branch is going to go off to the QA team next week. Maybe you want them to commit to their own branches, and you want to look at the code and actually pull that in very carefully on a case-by-case basis. Maybe you want your devs to actually submit pull requests and say, can you please pull these changes in? It just gives you that sort of that quality gate, that ability to look at it before it goes in. So now if I go into that repository, let's have a look. I should have a README. Yes, so I can make a README file here. Okay. So it's just make a change at the end here. So lost the ability to type, but that's okay. What would you describe TechEd as? Global. Microsoft's biggest, bestest IT conference. Okay. So I've got a change here. There we go. I'm going to add that change into my staging area. I'm going to commit it. Added something useful in the README. I mean, it wasn't massively useful if I'm being honest, but you know. So now then, let's have a look at the remote. So I did a git clone, remember? I said clone that repo over on that server. And it set these remotes up for me. It set up an origin remote, an alias of origin. Okay? And here's the location of it. So I'm going to do a push up to my repo on GitHub. And I'm going to push it up to origin, just the master branch. Credentials. So my username and the password should still be in my control V. That's not good. How do I know it was the master branch? So I only had one branch running at the time, so we could have checked the branch. I'm pretty sure, did I put the wrong username in? I'm pretty sure it's just Ian Randall. Let me just grab my password again. I might have lost it out of the copy. Password, paste. Okay, so it's going to push those changes up. If I wanted to just quickly look at what branches I've got, I can just look at git branch and it'll list out the branches I'm on. It's going to stick an asterisk next to the one I'm currently on, and I can just check out the one I want and it'll put me on the right branch. So that's now up on GitHub. If I go to here, I have a commit here, and I've added something useful in the README. Okay, so what I want to do, I'm going to go into the pull requests here, and I'm going to create a pull request. Now, if I'm lucky, my friend Brendan is going to be sitting watching for this. Added a useful thing. So I'm going to send that pull request. So I'm hoping that my mate Brendan's going to be listening to this and he's going to do something. If he doesn't, he doesn't. That's fine. But what you'll see is he now has the ability. He's just got emailed to say Ian Randall has submitted a bug. He's submitted a feature. He's done something, and he would like you to pull that change into the code base. Okay? He now has the ability to log in and to discuss that feature. So maybe this is your team leader getting emailed that your developer has made a change, and he can discuss that change within the context of the code itself, and he can open up the line that's changed and said, "You've missed a semicolon here, mate," or whatever the answer is. So that's gone within. We can check back on it later. Oh, there he is. Oh, hi. So there you go. So we can start that conversation. We can have that conversation. Okay. So that's pull requests. Okay. So what about TFS? I've completely lost the time. What time does this finish? 55. Okay, so we've still got a quarter of an hour. Okay, so we might not go the full quarter of an hour. We're getting close. Okay. So how does this affect us? Because we use Visual Studio, right? We're Visual Studio users. Maybe we're happy with TFS. Maybe we're looking for another option. So with Visual Studio 2013, Microsoft are offering Git support. Now, in the past, you might have expected this to have been some kind of DVCS that kind of did the same thing as Git, but it was Microsoft's own thing. They've done stuff like that in the past, let's be honest. This is really Git. So they really have taken the whole concept of taking Git, the technology, and putting it into the files and the folders that contain your source code, and putting a UI in Visual Studio that allows you to interact with Git. Okay? Now, it's a fully integrated experience. It's in Visual Studio. It is brand new. It's not as powerful as, obviously, as the command line. There are other GUI tools available as well. Certainly, if you're on the Windows platform, then Git Extensions is a very good UI tool. But the fact that this is a Microsoft tool, the fact that this is a maturing Microsoft tool, it's just going to get better and better. Okay, so let's have a quick look at that. Okay, so I don't have Visual Studio 2013, but what I do have is the Git plugin for Visual Studio 2012. So this should be fine. Just fire this up. Okay, so I'm just going to create a new project. And here's my, it should be a familiar sort of experience. Here's my list of options. We'll just create a console app. And you can see down here we've got this option to add to source control. So we're going to say yes. And now we get a new option. It should pop up and say, what kind of source control do you want? Okay, can you guys read that? Do you want Team Foundation? Do you want TFS? Or do you want to use Git? Okay, I want to use Git. So now Visual Studio is doing that work. Now it's doing a Git init and creating the .git folder for us and putting all the bits in it. Okay, so again, this is sort of should be very familiar now that you're all experts on how to add your changes into the staging and how to push those into your repo. So you make a change. Okay, and I can go to my my source control, which is here. Where's my source control? Okay, so that's my source control. And here we go. Okay, so let me just make that a bit bigger. Okay. So this is that integrated experience that we talked about. If you were to go into the console and you were to go Git status, you would see that these files have been added, these changes have been made. This is the kind of the more familiar TFS integrated experience. And this really, and I just think it's worth repeating, this really is a real Git repo. It's not a Microsoft Git repo. It really is Git with the Visual Studio layer on top. Okay, I'm going to wrap it up there because that's enough. So let me just go back to my slides. Okay, so thank you very much for listening. Thanks for sticking with me right to the end. I know it's a long, hard slog to get right to the end of a 4-day tech conference and to listen to someone banging on about source control. Do feel free to get hold of me. I'm Ian Randall. I'm a full-time .NET developer. I work at spendvision.com. And I mentioned it before. This is not the opportunity to let you know that we're hiring. Don't come to me and swap email addresses and let me know your CV. It's not appropriate. There's nothing related. How can I give you related content? It's finished. It's done. I'm KiwiPom on Twitter. You can reach me on this email address. I love chatting about code. I love chatting about technology. Reach out, say hi. Thank you very much.